Hey everyone, welcome back to another episode of SciKid Sirish. Today we're going to be discussing spin. When you're looking at subatomic particles and particle physics, as well as quantum mechanics, spin is a crucial aspect. It's one of the fundamental properties of every particle that we know of. And spin, despite the name, has nothing to do with these particles actually spinning. The relation is that spin is measured in units of angular momentum. Here it's joule seconds. Spin is more related to the magnetism of a particle than the particle itself spinning in any way. And really where it comes from is special relativity. When you apply special relativity, the kind of physics that applies to particles that tend to move really fast, to these subatomic particles, this whole phenomenon of spin and angular momentum emerges. So it has nothing to do with the particles themselves truly spinning, but rather it's an intrinsic characteristic that all these particles have. Spin matters because it changes what these particles act like and what they do. One of the biggest effects of spin is noted with the Pauli exclusion principle. The spin here can have a half integer spin, that's 1/2, 3/2, 5/2, and so on, or an integer spin like 0, 1, 2, and so on. Here, if it has an integer spin, this particle is known as a boson. And bosons can be in the same state at the same time, whereas fermions, particles with these half integer spins, they can't. This is why, for example, two neutrons can't be in the same place at the same time. But photons can be in the same state at the same time. That's one of the biggest differences that's caused by this difference in spin. Another characteristic is magnetism. So here, we need to look at the different spin states of a molecule. And we'll start with the example of an electron. An electron has a spin of 1/2. And to go from that spin to a different spin state, you just subtract 1. So it has spin states of 1/2 and -1/2. So here you have those two possible spins. So we refer to the 1/2 spin as an up spin and the -1/2 spin as a down spin. And these spins, you look at them through the lens of a magnetic field. When you shoot a particle through a field, based on the spin, it'll either deflect up or deflect down. And that deflection was measured in a particularly famous series of experiments. It was the Stern-Gerlach experiment, where they fired these neutrons through a field, and they would set them through multiple of these magnetic fields. And that really proved the concept of superpositions. This is where spins are most often seen. So here we look at them often in superpositions to see whether a particle will have an upspin or a downspin. And that's one of the biggest places where spin comes up. Looking at spin, it's a crucial aspect of particle physics, and its intrinsic properties are ones that every particle must have. Spin is critical to understanding particle physics, and this is how it works. Thank you.